Hi, my name is John Payton, Business Development at Sequire. I'm here to introduce Lightwave Logic Inc. Lightwave Logic is a development stage company focused on the development of photonic devices and nonlinear optical polymer material systems for the fiber optic data communications and optical computing markets in the United States. Lightwave Logic Inc. was founded in 1991 and is headquartered in Inglewood, California. Lightwave Logic team, take it away.
Hello, this is Michael Levy from Lightwave Logic. I'm going to give an investor presentation for LD Micro. I have the normal safe harbor slide. And I'm going to give a Lightwave Logic overview on this slide. As we can see on this slide on the left-hand side, what I've circled in red is good news for us. We were successfully uplisted to NASDAQ on the 1st of September 2021. The good news is that we did an organic uplist. We did not do a reverse split, and that is quite unusual and quite rare. In the meantime, we've been invited to speak in investment conferences and international technical conferences, just like the international one on optical communications, ECOC, last week in France. As you can see from the right-hand side of this slide, we have a very strong balance sheet, and we're looking to strengthen that so we can accelerate product to market. We also have a very strong patent and IP position with over 70 patents and patent applications, and we have freedom of manufacturing. And we can see from the right-hand side, I put in as of the 22nd of December, the share price and the market cap, and our cash levels from our last quarterly review. Our company headquarters is based in South Denver, Colorado, and you can see the building in the lower right-hand side. And so on the 10th of September, you can see from the slides, was a great day for Lightwave Logic. We were invited to close the NASDAQ market on the 10th of September 2021, which was just over a week ago, by ringing the closing bell. And you can see the team here being shown in Times Square and generally really, really excited. And in fact, not as excited as you can see from this slide. This slide shows that exactly 4 p.m. East Coast time, we closed the market. It was a great day for the company and a great day for the investors, the shareholders, the stakeholders, and the employees and the board of directors. So in terms of Lightwave Logic and the impact, you can see our building on the top left-hand side. We're a technology platform. We're designed to help scale the existing internet structure by providing transmission of data at higher speeds and lower power. We've been saying this for 4 years. We have not changed our message. It's the same message we've given, and it's essential for data communications and the telecommunications markets. And we do this by leveraging our proprietary electro-optic polymer materials to create very fast, very low power photonic devices that convert the data from electrical to optical signals on the fiber optic internet. We have technology evaluation underway, and we have in-house control of material supply, device fab, and package design. And so the impact is faster internet, lower power consumption. So in terms of applications and markets, so we solve the headaches of the internet. We can see schematically the fiber optic network shown on this figure here, with the ones and zeros going from one building to another building. The internet carries this data, and it needs to grow in speed, and it needs to keep power in check. And what's required now is radical innovation. And we have that radical innovation through our photonic devices. And we actually provide that radical innovation through our electro-optic polymer technology. In fact, if you look at some of the growth in the traffic that goes on the internet, you can see a typical graph on the right-hand side showing a 25% growth in an increase in traffic. And I'm sure that's going to grow even more now that we're learning to use video platforms at home and do a lot of virtual reality in terms of conferencing. We know the network capacity is fallen behind the traffic growth. We know consumer level data usage is up. We know the network cost and energy consumption have become the new hotspots for data providers. And we also know our technology solution, polymers, can transform the internet with much better performance. In fact, if you look at a couple of market slides, there's one here. These are some of the components you find on the internet, fiber optic transceivers. You can see this market growing over the next decade to about $80 billion in terms of forecast. The fiber optic transceivers are $53 billion, about 2/3 of that market. That's a huge opportunity and a perfect vehicle for hybrid photonic integrated circuits, which is the platform that we're working on with our polymers. And so we see these markets explode over the next decade. In fact, if you look at these markets, you see it in the lower left-hand corner, fiber communications, high performance computational work, DCI interconnects, data center interconnects and data centers. These are huge forecasts over the next decade. They're existing markets, but we can also see there's new opportunities where photonics can become ubiquitous over the next decade. And this is the opportunity of using our technology, the polymers, in different types of markets over and above fiber optic communications on the internet. And in fact, our proprietary electro-optic polymer technology can be extended to more applications. You can see the current applications on the lower left-hand side of this slide, initial prototypes and target speeds. You can see on the lower right-hand side the future applications, non-communication applications such as LiDAR, automotive, sensing, displays, etc. Anywhere where light needs to be switched very quickly at low power, because our electro-optic optical modulators switch light very, very quickly, and it does it at very low power consumption. So our polymers enable faster devices, lower power solutions today. And in fact, what are our competitive advantages? Well, we save energy on the network. We reduce network energy costs. We enable, as we can see from the center photograph here, much faster networks, much faster data traffic on the internet. And our engineering advantage is the fact that we have a technology platform that is flexible. We have full control of the material science of the organic electro-optic polymers that gives us greater flexibility in device design and performance. Our technology addresses the customer pain points. And in fact, when we target customers, you can see we can actually put sales into optical component suppliers, high-speed optics manufacturers, network equipment manufacturers, but we also provide the value to the internet service providers. These are the influencers of the internet. So we have the potential to enter the market in many verticals here. And what I'm showing here is typical players that you find in this value chain. In fact, our business model and commercialization roadmap is actually multi-pronged. It's not only just selling components or optical components. It's actually the licensing of technology and the technology transfer. And you can see that the typical process I've shown from the arrow at the bottom. But the takeaway at the bottom of the slide is our three-pronged business model with customer engagement process is going to allow us the flexibility to be successful in this marketplace. In terms of intellectual property, which is really important for technology transfer and for licensing, we've built a really strong intellectual property portfolio, over 70+ patents and patent applications. That gives us freedom of manufacturing. That gives us the opportunity to do technology transfer, especially to entities like large foundries or OEMs. We can do licensing to these types of players or contract manufacturers or CMs. And you can see from the table below, we have a number of different ways where we've built our patent portfolio. For example, we've acquired patents from Lumira and Gig Optics, which were the original electro-optic polymer companies that produced high-speed optical modulators, 5 to 10 years ago. We're filing innovative polymers. We're filing innovative silicon photonics patents. So we have a powerful patent portfolio with freedom of manufacturing, and we're really proud of this. In terms of technologies, this is a very technical slide. I don't expect everybody to comprehend the details here, so perhaps you might want to look at this afterwards. But essentially what this slide says is there is a green wall here, and to the left-hand side of the wall is where commercial optical devices are today. Those are those yellow, those spots that are black, gray, and dark red and blue. These are commercial devices today. And on the right-hand side of this wall is where our optical modulators play. As you can see, we have much more increased in speed for polymer modulators. We break through this wall. We have faster and lower power optical switches, optical modulators. You can see from the bottom right-hand side of this slide, our polymers are 3 times faster than existing devices today. And so we have headroom to go much faster. And you can see, as this translates into data rates, and you can see the green colors and the pink and the purple colors, much faster data rates, whether it's 1 lane or 4 lanes. And this is really, really exciting. Our technology breaks through the wall. In fact, this is what a modulator chip looks like. It's actually a polymer, electro-optic polymer that's placed onto a silicon platform. It's done in a traditional fab. The polymer is spun on using traditional spinners. We use standard fabrication techniques like wet and dry etching and metallization. And so very, very standard, very easy to implement into big silicon foundries. And so this slide is the natural integration with big foundries. We have 3 different platforms to put our polymers onto silicon. The polymer stack, which is the traditional 3-layer stack of an optical modulator. We have Polymer Plus that puts our polymers onto silicon photonics to boost the performance of silicon photonics. And then we have the polymer slot, which is a very small optical modulator, which is really tiny, that is perfect for integration in very small and miniaturized integrated photonics platforms. But essentially, the takeaway at the bottom of this slide is we turbocharge your silicon photonics and integrated photonics platforms with our electro-optic polymers. And our polymer attributes vis-a-vis the competition are quite impressive. These are the traditional spider charts you see in the technical world. And a spider chart is a diamond. And you see metrics here of high speed, size, stability, and low power. And if your device, your technology covers the full diamond, then you've got something that's really good in terms of covering all the metrics. And we can see the competition, silicon photonics in blue, indium phosphide in green, lithium niobate in red, barium titanate in purple. And you can see the polymers in the gold color, and they cover the triangle very well for the polymer stack, for the Polymer Plus and the polymer slot. So here are the technology strengths and weaknesses, and we can see polymer platforms are quite attractive. And so in terms of recent performance, our recent performance when we say our modulators are really fast, they can switch over 100 gigahertz in optical 3 dB bandwidth, which is far exceeds indium phosphide, lithium niobate, and silicon, as you can see from this graph here. So our polymer modulators outperform competitive semiconductor technologies, and that's really exciting. And in fact, our route to maturity and volume, as you can see from the dark green arrows, we're focusing on prototyping and piloting stage now with the TRL scale, which is a technology readiness scale. And we're certainly positioning ourselves for the gold arrows, which is the manufacturing. And so we're really excited to be in this phase of the evolution of taking our technology to high volume product. And in terms of our polymer business roadmap, I've shown this slide before, but I focused on one part of it, which is the foundry partnering. We can see we've gone from polymer performance and reliability and robustness with our materials, with our electro-optic polymers, to customer interaction, testing, evaluation. And I'm focusing on foundry partnering because that's the critical stage now. That's how you position our technology to scale for mass commercialization. So the current engagement includes foundry partnering. And let's take a look at this foundry scaling, because it's really important. If you want your technology to be ubiquitous across the internet, across the world on a global scale, you've got to think about working with large silicon foundries. We have a small silicon fabrication plant in our facility here, but to really get to scale, you've got to work with these types of players. And these players today are hungry for the opto business, for the photonics business. So they all want to work with companies such as ourselves. And the CMOS, these are CMOS fabrication plants. They want silicon photonics as a new upside for them. And the PDKs, the process development kit, will drive the integration into integrated photonics platforms with these types of players. And if we look at our technology roadmap, we can see some interesting things come from this roadmap. On the left-hand side, we focus on one word, the uniqueness of our platform. We have unique chemistry and materials. We have unique chip design. We have unique high-speed performance, to go at 100 gigahertz or more, which is really high speed, which is 2 to 3 times the speed of the devices you see on the internet today is really unique. And we have unique Polymer Plus PIC platforms. And you can see from that integration line on the lower right-hand corner, silicon photonics integration for the foundry PDKs. This is really important for the roadmap. And our technology roadmap's not only the direction we're going with foundries, but our uniqueness value to the industry. And in fact, when you're partnering with silicon foundries, you have to be able to include our polymers into the foundry PDKs, their process development kits. And the PDKs is their library, their set of building blocks to lay out the ideas for the photonic integrated circuit. It's provided by the foundry for silicon photonics, and it allows you to create innovative designs quickly and to ramp volume at a mass commercialization scale, which is the perfect vehicle for our technology polymer platform. PDKs are the route to partner with foundries. And in fact, just last week, I was at the European Conference on Optical Communications exhibition, and we were given an exhibition industry award for optical integration, and that was given to Lightwave Logic, and I'm very happy to receive that. And there's a photograph there as I just received the glass award. And so this is a third-party review by the industry that really is excited about our platform, just like we are ourselves. And this happened on the 14th of September, 2021. I believe there's a press release out if you look at our website. In fact, in terms of our company, we're really focused on positioning ourselves with leadership. This is our board. As you can see, our management board is with established and mature professionals. We have very high level CTO folks from Corning, DuPont, JDSU, Nortel Networks, Menara. We got some really deep experience in fiber optic communications and the technology that is the backbone for the internet, as well as very experienced management folks that have CEO leadership. And so we have a very, very strong team, and I'm pleased to have this team to help support us. But what's more with Lightwave Logic is that we have an extremely strong technical advisory board. I know an advisory board is unusual for a public company, but this is a very technical play. And we have 3 doctors here, 4 doctors in different facets of the business that have all had CEO or CTO type positions in different types and different facets of the technology. And these folks are technically reviewing and evaluating our strategies to engage with the customer base and make sure our technology has the impact we want it to really change the internet and give value to the customers who really are putting the technology into the internet. So to summarize the presentation, we are partnering for success. Our technology platform is working to help scale the existing internet structure. It's an enabling technology. Our technology platform is designed to transmit data at much higher speeds across the internet at much lower power, which is absolutely essential for data communications and telecommunications market. And we're leveraging internally engineered and proprietary and highly patented electro-optic polymers to create super fast optical switches, which are optical photonic devices that convert data from electrical signals to optical signals. We work with foundries, we have packaging partners and transceiver partners that are helping position Lightwave Logic for future mass commercialization, high volume production, and we have technology evaluation underway. So we're leveraging our partners to commercialize our technology in photonics. And it's really, really exciting, as you can see from the earlier part of the presentation. We're all really excited to close the market on the 10th of September, NASDAQ. And so it's a really exciting time for us now that we are uplisted to the NASDAQ Stock Exchange. And for further contact, I would encourage you to reach out to our investor relations Either Greg or Luke will be happy to take your call at these web addresses. Thank you very much.